if you had memorized it. So I'm not saying you have to memorize it, but does anybody remember those amounts on the normal curve where if you go out one standard deviation, then it's like some percentage in there? You remember what it was?
34.
34 is the first one. Good. This is 34. And of course, the other way is 34. And I said, nobody's probably going to remember the next one. Does anybody remember it? Yes? 13.5. He's right. And everybody write these down because it's the question that I want to do is like a practice test question is going to involve these. And you probably don't have them memorized. He did. I think I got the next one. Anybody think you got the next one? Yep.
2.25.
I think it was 2.35, but I'm not sure. Can anybody verify?
Oh, it's 3.5.
Is it 3.5 or 2.5? 2.35. Okay. And then last but not least, there's one little shred on the very, very end that makes it add up to 100%. Anybody know it? 0.15. So 2.35 here. 0.15 here. That is not 15%. That is 0.15%. All right. Next test question. If this is 100, do you remember that whole IQ thing? 100 is the average. And the reason this is so good is they have so many data points. And 15 is the what? A little louder. It's the standard deviation. Would you please write in what these two numbers are then? If 15 is the standard deviation, you should be able to do that. Okay, so here's what you should have been thinking. Well, it's going up one standard deviation, makes this 115.
Michael in there?
Sorry, I don't think. Are you?
Looking for Michael.
Okay.
There's no Michael?
Okay.
Sorry.
No Michael, right? No other name Michael?
That's unusual. All right, so then we go back 85 this way. Who had 85 and 115? Raise your hand if you did. Okay, good. You're on the hunt here. So here's how the question would probably look. How many percent of people have an IQ that's at least an 85? Use your calculator. Figure out the answer. What percent of people have an IQ that it's at least an 85? You'll need your calculator for this. At least an 85. So you're going to be adding up a bunch of numbers. Tell me what numbers you added, sir. And this is just my terrible writing, though. That's a 34. You're talking about Truckee, I think, and he's not in here today. That's the problem.
Marcel, want me to bring you? So he's not here today?
Not here today, sorry.
Okay, thank you.
All right, so back to, we were adding up, and my terrible handwriting, that's a 34. 34, 13.5, 2.35, add 0.15, and you add them all up. Final answer, what'd you get?
84%.
Can anybody verify 84%? Okay, cool. So that's 84% of people, and this is an interesting fact, and this is real world. I didn't make these numbers up because I know what the average IQ is, and I know what one standard deviation is. You can look them up on Google. And then this is a fact. And it's kind of interesting. It's almost as simple as 85% of people have an 85 or better IQ. What does that mean about people that are below 85 IQ? It must be, can you do it in your head? If it's 85% or above it, then what must be below it? Did anybody figure out it was 16%? Yeah. So 16% of people How about below 85 IQ? Okay. All right, so that's one thing you learned recently. Now I'm going to teach you something called scatter plots. And it's pretty simple. If you graph a bunch of dots like this and it goes up, take a guess. Do you feel like that's positive or negative correlation? Just say it if you think you know it. Do you feel like that should be positive or do you feel like that should be negative? This is what's called intuitive. Yes?
I think it's positive.
You are correct. It's positive. If something's rising, it's generally positive. Okay? So that's positive correlation. That would be like, for instance, you lift weights more, you get stronger. You know what I mean? You do more of this, you get more of that. Another one would be you eat more calories and let's make it your dog. You feed your dog more calories, your dog is going to get bigger. It's going to get larger and larger. We have a cat that's actually got the opposite problem. It's too skinny. And we brought her to a cat show. This is my daughter's thing, really. And she was losing points. She was actually like considered a really good cat, except she was really skinny. So we've been like trying really hard to get her to eat, and it's been working. So she's gaining weight. So the next cat show, which is this weekend, we're thinking she's going to get higher scores. So anyway, as you feed the cat more, the cat weighs more. Okay, what's something that goes down like this? Dot, 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 dot. Because the real world is messy. It's never a straight line. You do more, and something goes down. Like here, you do more, but it gets lower. Yes?
Negative correlation.
Yes, this is a negative correlation. What can you say about like a real world thing where if you do more of it, something will go down? Yes?
Spending time and like papers going down.
Time and then papers? Help me understand papers.
Like finishing work.
Oh, okay, so how much homework you have left. If this is time, you spend a lot of time, then you have less and less homework left. If you only spend a little time, you have a lot of homework left. I like it, that works. That's called a negative correlation. Next, what if something is super tight, like almost a lock? Like you spend 1 extra hour and you automatically for sure, will this be something like work? Do you get, if you work an extra hour, your boss has to pay you for an extra hour? 1 extra hour, you get more money. 1 extra hour, you get more money. Okay, that is called a strong correlation. It just goes straight up. In the real world, there's other factors like maybe you work and you get tips. And some days you get good tips and some days you don't get good tips. And so you get this, yeah, you make more, but it's kind of like jumps around more. Okay? So that's still a positive correlation, but the one before where it was just a straight line, that's a strong correlation. And there's a name for it. It's called R value. If you have perfect R value, it's like you have a job where you get paid by the hour and it's simple. It just goes straight up. Dot, 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 dot. They're all in a perfect straight line. And that would be an R value of exactly 1. 1.0. What if you're kind of like this, where it's not perfect straight up, but you can tell it's going up, and there's definitely a correlation. We have to have at least a 0.5. What if it's less than a 0.5? Then you don't have a strong correlation. What if you have like a 0 correlation? Then that means it's all over the place. It's like the number of words I said in the last minute compared to the price of licorice in Afghanistan. They're not related at all. You could graph them, wouldn't have anything to do with each other. The dots would be just everywhere. Okay? That's called no correlation. All right, so let me show you. You got this. Is that positive or negative? No, that's no correlation. What's its R value? 0. Okay. You got this. That's pretty dang close to perfect. That R value might be like 0.9. Because there's a couple points that are off a little bit, you know. Maybe they're not exactly in a straight line. So that's 0.9. What's this? pretty much perfect, but down. -1. Because it's negative, it's going down. So that's a -1 correlation. What if it's pretty dang good, but not perfect, but going down? Then that R value is probably like maybe a 0.6, but a -0.6. Okay, so what's no correlation? 0. What's perfect correlation? 1. Or if it's down, -1. And anything in between is somewhere in between. I have this ACT class that I teach, and I have this practice test, which is meant to be kind of like the ACT, but it's not the actual ACT. The actual ACT takes 4 hours to take. And my practice one that I made only takes 1 hour to take. But it's meant to predict how well you'd probably do on the real ACT. Well, I got a R value of 0.6 of my test. That means there was a correlation, but it wasn't super strong. In fact, it's considered decent correlation. It's above 0.5. If I had had a 0.9, I'd have been like, dang, my test is almost perfect. It predicts the ACT like perfectly. 1.0 is unheard of. Nobody ever gets like a perfect correlation unless you design it that way. Like your boss, you work 1 more hour, he always pays you. In the real world though, sometimes your boss kind of rounds the other way for you. You don't get quite paid enough. You have to work an extra few hours. He doesn't count it in your paycheck. There's mistakes in your check. Almost never a 0, 1.0. Okay, so how do you do this on a calculator? We are going to need to enter, just before we do it, pay attention, we're going to have L1 and L2 data. We're going to put things in both L1 and L2. That's under stat either way. So everybody hit the stat button. But before we actually delve into this, there's this weird setting that seriously, I've only had to touch a few times in my math career. It is called Diagnostics. I bet you none of you have ever touched the Diagnostics setting before. So we need to go into the catalog and we need to change your diagnostic to on, because that'll tell you the R value. Okay, so how the heck do you do that? Do you guys see the 0 key? Look above the 0 key. What word do you see? Catalog, correct. Everybody hits the catalog button. So you're going to go second, 0. You don't have to actually hold the catalog or second down. Just press it. And if it isn't working, just clear off your screen and get it completely blank, because some of you guys are in the wrong menu here. Just clear it. Just go second quit and get out of there. Get back to a blank screen and get to the catalog. You'll know because the first thing on the list of the catalog is ABS, I think. Can anybody verify that? Okay. If you got ABS up, then you've got the catalog up. Okay. Now, I need you to be ready to help the kid next to you, because seriously, there's going to be 4 or 5 people that don't get this. All right. First thing we're going to do is you're going to arrow down approximately 1,000,000 times until you get to the thing called diagnostic. I know it's 1,000,000 arrows down, but it's alphabetical, so you'll be able to tell you're getting close. And tell me when you see diagnostic. There's off and there's diagnostic on. Do you guys see that? Okay, go to diagnostic on and hit enter. Now, it says something on your screen. Doesn't it say diagnostic on? Actually, hit the enter there. There we go. After you hit it, does it say done? Diagnostic on, and then it say done? All right, would you please compare that to the person across from you? Make sure everybody's done the diagnostic on thing. You guys compare. Diagnostic on. Make sure it says that. If they don't get it, help them find it.
What does it don't?
It should say diagnostic on and hit enter. Okay, good. Now, there's something that will now pop up that would never have popped up before, and it's the R value. And I'll show you where we get that. Once the diagnostic is on your TI-84, then we're going to go into list 1 and list 2, and we're going to type in some data. So everybody go to stat button, edit. And whatever's in the L1, hit DEL until it's deleted out. Now, some kids by this point have somehow by accident deleted their list 1 or list 2. Is there anybody that doesn't seem to have an L1 or an L2? Could you bring your calculator to me and I'll fix it?
I just did.
If you just deleted it, I can help you undelete it. You just gotta hand me your calc. Yeah, your list 1 disappeared, so I'll go second plus 7, and I got an arrow over to all. Enter, reset. That'll fix it. Okay. So let me think. Second, 7. Second plus 7. There.
Thank you.
Is your list 1 back?
No, I'm just deleting them all.
I can help you to get list, you need list 1 and list 2. I can reset your calculator. It's under second. Oh,
I just deleted them all and
oh
renamed
my
them.
goodness. Okay. I've never seen you do that before. L1 and L2. Ready? Okay, now we're gonna put some data in. In L1, we're gonna put in the numbers 1, 2, 3, and 4. Say 1, enter 2, enter 3, enter 4, enter. Okay? Then in list 2, arrow over to that, and put in, I'm going to make this super simple. We're going to take this number, and I'm going to triple it, and that's going to be 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, and 4 times 3 is 12. Do you get that that is perfect? So the R value on this puppy ought to be perfect, which means it would be what? 1.0. Okay, but I want to show you that the most time in the real world, it's not going to be perfect. So we're going to tweak one of these numbers. It should be 3, 6, 9, and 12, but we're going to change it to 13. So if you have to, go back and delete this number and make it a 13. That will show you an R value that isn't 1. It'll be like, oh, it was close to 1. I'm going to give you a 0.9 or something like that. All right. Anybody have issues with getting these numbers in? You got them in? Are we good? Okay. Then hit the stat button again. And now arrow over to where it says calculate. And now don't do the one variable stats thing. You might assume we're doing that. If you did that already, undo it by second quit to get back to this stat, calculate. What we're doing is called a Lin Reg. That stands for a linear regression. Hit Lin Reg and hit enter. Hit enter once you get it out on the screen there. And you'll see Lin Reg, blah, 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 and it says R equals. Do you see how it's really close to 1? If it worked for you, your R at the bottom, it should say R equals 0.99, let me look at yours, 725. Can you guys verify that? Is that what you got? Okay, cool. Do you get how it was really close to perfect? We know why it wasn't perfect, because we tweaked that one last number. But it was really close to a straight line. Okay. Now, that equation that we just created there says y equals ax plus b. And then it says what a is, and then it says what b is. I think some of you are smart enough to tell me what the equation is now. Round it to the 10th place. So I think the equation, you got it on your screen there, is something like 2.6x plus 7, but that's not the right answer. Would you please write what the actual equation is for this data? It says it on your screen there. It says y equals ax plus b, and then it tells you what a is, and it tells you what b is. You've got it. Can you read it to me?
Y equals 3.3x minus 0.5.
3.3x minus, is it 0.5?
Yeah.
Thank you. There. Does that look like an equation to you? It's got a slope, it's got a y-intercept. And what this does is this is a model of the data that we gave it. You remember how it was almost perfectly multiplying everything by 3? But when I changed that one last number, it made it 3.3 that you multiply everything by. And you have to subtract a half. So it tweaked the model just a little bit. We're going to go back into our data and we're going to change it back. Everybody go here and change this. I know you know it's under stat edit. You're going to change this from a 13 back to a 12. And I think when you do the linear regression, it'll make sense to you then. I hope it will. So get the 13 changed back to a 12, then do the linear regression, and then I hope you'll see that this number will make more sense, and this number will make more sense, and your R value will be what? 1. Because it's perfect now. And it's not 3.3 now. Go ahead and hit enter. You just haven't hit enter yet. Lin Reg. As soon as you get the Lin Reg up on the screen, you got to hit enter. Enter. Okay. Can you hit go to? Go to the number 2. And then, okay. So you didn't tell it where to get it the linear regression from. Okay. Some people with the older calculators, I'm going to try this one more time. You might have to hit enter a couple times to make it work. If yours is not working, would you please bring it to me and I will fix it? Just hit stat, calculate, Lin Reg, and then hit enter now. There you go. All you got to do when you get to this point is hit enter.
Yeah.
Okay, then you go to, okay, and then I'm going to go to your stat, edit, 2, 6, 9, 12, okay, stat, calculate. Did you do this one right there, Lin Reg, number 4? And if I hit enter, whoa, I got to reset your calculator because something's messed up in your calculator guts. So I'm going to go second plus 7. That one. That one. Sorry, the calculator's fixed now. Okay. This is actually perfect. You just have to hit enter all the way down to calculate and hit enter. There it is.
Okay.
Our value is 1. And now it's a 3.0. We multiply by 3. You just had to hit enter like 5 times on your calculator. So these calculators, come on around. The only thing that's wrong with yours now, remember how I had to reset it?
Mm-hmm.
Then I got to go back down and do that catalog, arrow down to diagnostics on. Remember that deal?
Yeah.
And you'll only have to do this once. You don't have to do this a million times. But because we reset yours since then, your diagnostics turned off. So now, if I go back to stat, calculate the linear regression, enter. R value is 1 now, and A is 3, B is 0. It's working. Anybody else's calculator messed up? I'll fix it. Okay. So I hope you figured out at the end that it was 3x, and then there was nothing at the end. You could say plus 0 if you want, but you could just say y equals 3x. Isn't that what we were doing, timesing each x by 3? Yeah, that's what we were doing. Okay. You have learned 2 powerful things there. One is how to find a correlation coefficient. That's the R. The second is a linear regression equation. That's this. All right, now when would you ever use this in the real world? I'll tell you. Every now and then, they will find a hand without a body. I'm not kidding. They'll just find a hand. This happens a lot down in Florida, where in the swamp, something has eaten the rest of the body. Now, usually, to be fair to the alligators, the person died and then was thrown into the swamp to try to get rid of the body, because bad guys do that. They don't want you to find the body because then they don't want to get connected to it. So anyway, body is eaten by the alligators. There's a leftover hand. And all of a sudden, some dog is playing in the backyard, comes home, it's got a hand in its mouth. That has happened, seriously. Okay, so then they're trying to figure out whose hand this is, right? What they can do is measure one of the bones in the hand, and they can tell from that, by looking it up on a chart from a linear regression equation, they can go, oh, this came from a 6-foot tall male. Isn't that amazing? Just by measuring a bone in a hand, they can tell how tall the person was. Do you get that the taller you are, the bigger your hand bones are? That makes sense? Can you imagine somebody super tall with like little toddler hands? Would just look ridiculous. Okay, so there generally is a correlation. Is it perfect? No, the R value isn't 1, but there's a strong correlation. Now, what I've done in the past, come on in, is I have actually had people measure their fingers and then measure their height, and we can actually do that. It just takes a long time. So I'm going to make up some data. So everybody go back to your chart here, and I'm going to show you an example of how this would work. So erase all your numbers in your chart. Your L1 and your L2, get rid of them. Delete them all. Go ahead, right now, in your calculator. Delete out all your L1 and L2. Delete them all. And now, which hour are you supposed to be in? Yeah, this is 4th. It's okay. It's a Wednesday, and so everything's shifted back, on Wednesdays.
Yeah, you guys have it.
All right. He was so confused. All right, so I'm going to make up numbers. Person has a 6.1 inch, and this is going to be pinky. A length of their pinky, 6.1 inches. No, centimeters, sorry. And let's say that goes with a person who is 192 centimeters tall. Would you agree if we found or measured a 6.3 centimeter pinky, you'd expect the person to be taller, right? So we're going to go with 194 centimeters tall. If the person is 196 centimeters tall, we'd expect the pinky to be even bigger. So let's go with 6.5. With that much info, you can make me an equation with that thing called Lin Reg. Remember, you hit stat. Calculate the linear regression. I want to know what the R value is, which should tell you how tight how tight this was. Was this line really awesome, or was this line really weak? So go stat, calculate, Lin Reg, enter, enter, enter. And what did you get? Yes, sir?
1.
R value was 1. Holy cow. I just made up these numbers. And it's a perfect correlation. Is the real world that perfect usually? No. Because there are some people that have a little smaller than normal size hands for their body. And there's those people that have the really big hands for their body. That I had a friend, for instance, he wasn't even that tall. His hands were massive. He could palm a basketball completely. Like he just hold it up like it was a softball. Okay, and he had huge hands. And some people have that. Okay. So it's not normal. Real world isn't going to be that perfect. But I guess I hit a 1.0. Would you tell me the equation I got? Y equals, and you have to do this in your head. You change the A into the slope. And Alexis, can you tell me?
Y equals 10x
Plus 131. Do you get that this equation then could predict how big the pinky would be if I gave you a height? Okay, so let's say that it's your son who is missing. Heaven forbid. This happens, though, all the time. There's a missing person, and the missing person report says this person was 200 centimeters tall and blah, blah, blah. Now, in Minnesota or in the United States even, we probably wouldn't use centimeters, but let's say we are. Where would the 200 centimeters go? Which of these two was the X? The 6.1, 6.3, and 6.5, are those the X's? Yes, they are. Those are the X's. And these are the Y's. In case you don't know, X is always on the left and Y is always on the right. So if I tell you we have a 200 centimeter tall person, then the 200 is going to go here. And I can predict that it would be 10 times 200 plus 131. Well, that's a massive number. I just did it wrong. I said 200 was the x, and look at us, right above a y. Ah, dang it. Sorry. It would not go there. It would go here. 200 equals 10x plus 31. This would probably be the hardest question on your upcoming test, but I don't feel like it's that hard. Now that I put the 200 in the right place, Mr. Server, couldn't you solve this pretty easy? What would you do to solve that? What's first? Come on, trying to get x alone. Help out. What do you do? Yes. Yes. Subtract 131. And then help me out. What is this? 70, 60, 69? 69 equals 10x. And then what? Divide by 10. What's the final answer?
6.9.
6.9. And that is the length of his pinky. Because see, look at the chart. And 6.9 would kind of make sense for 200. You see how we could predict that? So they do this all the time. They'll find like a head. Ugh. And they can go, by measuring it and comparing it to charts of things that they already knew, tons of data from before, they can go, that was a 5'4" tall woman. And even though they only have the head, they can figure that out. All right, that's called linear regression. And that's called a scatter plot. These little dots that are all over the place when you graph them, that's called a scatter plot. A perfect correlation, or they're all on a straight line, would be a 1.0. A perfect correlation going down would be a negative 1.0. It has to be at least 0.5 to be decent correlation. What if there isn't any correlation? Then that's like a zero correlation, when they're just like data's all over the place. Okay? I feel like you've learned what you're supposed to learn. So, there is a Schoology quiz that I'd like you to start right now in class. And while I'm here to help you with calc issues, you saw there was like 4 people that needed help. Your calculator might get messed up next. Please do it now in class with me while I can still help you, okay? Start the Schoology quiz immediately, if not sooner. And that's all I got for the lesson for today.